What if you wanted to build low power, tiny Bluetooth devices, and you wanted them to be out in the world, but still talk to the internet? Well, one option is to take your phone, but the other option is to use something like gateways and allow your device to roam amongst all of them. Golioth Connectivity makes that possible from day one. So first off, let's define roaming. Roaming is when a Bluetooth device can talk to multiple gateways and it can hop from gateway to gateway to gateway without having to do a bunch of other stuff. You don't need to repair with each new gateway you see. That would be a roaming kind of scenario. And like I said, this just works with Pouch and Golioth Connectivity. So let's go take a look at how this works in practice. So here's our setup. We've got a Bluetooth device. This is the Teak board that we've shown a couple different times. This is actually still running the accelerometer based thing. So you're gonna see me shaking the Teak board, but that's just to enable it and to make it wake up. It's not checking in every 20 seconds like our default demo is. On the right side here, this is actually a Thingy 91X from Nordic Semiconductor. That's a cellular based device with a Bluetooth modem attached to it. And that's acting as a gateway. We actually have a reference implementation of this gateway where you can go and just download binaries that you put onto there. So you don't have to go and compile the project even. You can just go and download those binaries and have a gateway ready to go. Over here, this is the RW612. Also, there are binaries available for that. That's the Freedom RW612 from NXP. Very affordable Wi-Fi and Ethernet and Bluetooth solution, and Thread as well. And we use that pretty regularly here. So I've started with the cellular gateway on because I wanted it to already be connected to the cell towers. This device is actually on, but you can't see it. And this device is not yet on. So basically the Bluetooth device will be talking through the cellular gateway to start with. We'll show that working here. And then we're gonna turn off the cellular gateway and we're gonna turn on the Wi-Fi gateway, and we'll have it roam between the two. Now, obviously in any kind of scenario where you have a device like this, they're gonna be further apart. But because of the necessity of a screen here, we wanted to put them right next to each other. All right, let's start with a somewhat busy screen here, but on the top side, this is the J-Link that's connected to the Thingy 91X. That's actually talking to the NRF 9151 cellular modem that's on board right there. You can see it is connected currently. And then the bottom right, this represents that Teak board. So let's see. Well, we're gonna lose the, here we go. We can just refactor this. Okay, so we have the Teak board. It is currently on. It is currently connected there. I'm gonna just give it a little tappy tap, make that connect there. And what we saw happen almost immediately is that the device woke up, it started advertising, and then it talked to the cellular gateway here. And what you saw is this is actually uplink data. So this is actually end-to-end encrypted uplink data from the Teak board. So that's actually its accelerometer reading going up to the cloud through this cellular modem. And it was then also getting the downlink data, and that was that new message you saw there. Okay, so we can go and check this on the, let's go and check this on the console now to see what it looks like. Once I reload the status, we should see it just connected. So just connected a few seconds ago. If we go over to LakeDB Stream, we should also see its latest reading, which is, well, 1:22. This is the local time, and there is its accelerometer. So that was as it took that reading. So let's go back to the summary page here. We also see on the connectivity diagram here, we see the Teak 203. That's the name of this device, connecting through Thingy 91X-Black because I put that 3D printed case over it. Okay, let's go and refactor this now. All right, so pretty simple. I'm going to go and turn this one off. We won't really see any changes there. I'm going to go and turn this one. Video reload. That wasn't supposed to happen, but we do see, well, wait, can we see? Yeah, we see green lights here. And I'm going to switch over to the terminal view so we can see it connecting. All right, so we see this thing connecting to my local Wi-Fi network here. And it just got an IP address. And this is up and going. Now, what we shouldn't see is we should not see any change in this device right now because this is actually motion activated. So right now, the RW612 just woke up. It is up and streaming. And, well, there's nothing to do right now, which is great. So what I expect to do, well, let's first go and change the message so we can actually see in the real world that there's a new message coming through here. So let's go here, and we're going to go into this device. So this is the Teak 203. Again, that's the board that we're looking at there. We're going to go into settings. Let's change the value that streams across the thing. So let's say new roaming, new gateway, who dis. All right, a little bit of levity there. All right, so now we're back to here. Again, the gateway is just sitting there ready to go. The teak board is sitting there waiting for someone to give it a little tappy tap. And once I do that, we should see it do uplink now through this new gateway, and we should see the message come down through it. All right, so we see it woke up. It's talking through this new gateway. We see the uplink data, and now we see the downlink data. New gateway. Who dis? So, what did we just see? We saw a Bluetooth device connecting through Gateway 1, or Gateway ABC as we call it in the blog post, and then it connected through Gateway XYZ. And if we can imagine this teak device, this Bluetooth device, kind of walking down the road between different gateways, that would be effectively roaming between them without having to have any kind of data being handed down from the cloud to the gateway. The gateway is basically just shoveling packets back and forth because it's allowed to be on Golioth and it's allowed to transit data onto the Golioth network. And ultimately, the Bluetooth device is the thing that is end-to-end encrypted between the Bluetooth and the cloud, so the gateway itself cannot actually see what's going on there. Back on the summary page for the Teak 203, what we see now is that this has roamed onto a different gateway, and it now shows up on the connectivity thing. We can see, obviously, it's here. If I went and turned the cellular gateway back on, we could see it roam back onto the cellular device as well. So what have we seen here? Well, we've seen a low-power, smaller size device, not the smallest one out there, but that you could make these very, very small. It could roam onto multiple gateways without any additional overhead or communication from cloud to gateway. Because these gateways are allowed to be on Golioth, and because they're passing pouches along, which are the packets that are coming from this Bluetooth device that are end-to-end encrypted, the roaming aspect just works. And really, it is pretty magical, and it solves a lot of problems that I've run into in the past when I've built these same kind of setups. These devices are reference implementations, but they could really take any form you want to. We have some other content we're working on where a lot of different things can be gateways, and basically there are a minimum set of things that you need to do in order to make your device into a gateway, but as long as it's allowed on Golioth and it's on your project, well, it can push pouches along and your Bluetooth device can be connected to the internet. Bluetooth device connected to the internet. Remember that. All right, more demos coming. If you have any questions, go over to the Golioth forum, and we're looking forward to seeing you in the next one.